appreciate very much the previous speakers. I think this is a macroscopic growth, the macroeconomic contribution, and we are working on a paint on these are much microscopic aspects. That's what the chemist can do. And so this is a project that has a pretty long title, but that was the original project's name, and this is in collaboration with Professor Lee. And this is the project I want to acknowledge. It's funded by the New England Transportation Consortium, and it's a collection of DOTs from the New England area. And I want to first off acknowledge the technical committee, and each DOT has a representative, and they are overseeing the project from the beginning to completion, and provide a lot of advice, useful advice, and also thanks to people who provides the Michael Hillwin and Michael Socht and Richard Brown for the consultation and help. Also, in cases there are equipment loaned from the Rhode Island DOT, and so what we are talking about is what is called a duplex plant paint, and for example, the bridge. This is a highway bridge, and these were done with steel with a zinc coating, and then with paint on top of that. And there are several questions. This is actually, when it's done right, it's very good for bridge handrails, and what is some of the details of what makes a better adhesion, and what will not give you good adhesion. And let me see, there is an example is when there's not a very good adhesion, it has this paint peel off. And what factors are important in there? And so come back to our previous speakers were as an expert on the bridges, and so he knows all about that. There is a bridges guardrails is usually nowadays we have a zinc on a structural steel, and the zinc prevents the corrosion problem, or it's a sacrificial element for mitigating the steel's corrosion. And so, but then for both aesthetic reason and also for protecting this, make this zinc coating lasting a little longer, it's we have a paint. It's a primer paint, and then on top there is a top paint. So usually is these zinc metal, and I should have a slash a steel. Underneath the steel, zinc, and then there's a primer paint, and then there's a top paint. That is commercially is called a duplex paint system. And so, well, there is a net coat standard which is has been tested very well, and that is using instead of zinc metal on steel, it's using the zinc with in a primer paint. So it's a heavily more than 50% of a zinc powder in the epoxy and painted on steel. So instead of this zinc metal, and then with the primer and the top paint, and that it has been used and has been well tested, and there's a number of manufacturers as paint has been qualified. This is they have a qualified list for this paint. Okay, so what? Of course, that net coat works well. So what we want to use that as a standard, like a control, and then compare with the surface profiling. So-called surface profiling is related to zinc surface being roughened, and that has the effect of enhancing adhesion. And what method of surface profiling is good, and can we compare them? Then there is industrial knowledge is that if we use a liquid paint spray on the zinc surface, at least it needed to be well wetting the surface. And now that is known as the common sense. But what we want to try to see is there any measure of a wetting which we can correlate with the strength of adhesion. So what is the idea is that if we can evaluate a particular surface, zinc surface, and with a particular paint pairing, if that pairing, instead of waiting until that its paint is on and see whether they peel off, can we have a prediction of saying that well, these, if we use these set of a paint, is it better than the other? And this is the matching of different kind of surface, the zinc surface and the paint. So now there is a little, there are advocates for two kind of zinc metal coating on steel. One is called a hot dip galvanized coating, and this is you have a molten zinc and have this steel tube dipped in there, and when you take out, it's you get a layer of zinc metal on the surface. Another way is to have this called a thermal spray, where is you have this really vaporizing the zinc into tiny droplets, particles, and then electrostatically attracted to the surface you want to coat, and that is the zinc particles then aggregated into the on the steel surface. the difference there is that these surface, because it's a particle frozen on the surface, it just naturally rough. And well, then that's the advantage is that you don't need to roughen it anymore. And now in these, this is usually called a galvanizing. The galvanizing is more commonly used. And the drawback there is that you have the surface which is too smooth. And that too smooth a surface will lead to the paint adhesion problem. Okay, so what the idea of this project is to have compare this GB is a galvanized surface, and then we have a very commonly used method is use sweep blasting. This is like a gentle sandblasting, and to get the surface, the zinc surface roughened, and then apply the epoxy primer and then polyurethane top coat. That's one type of a coating. Another type is there is a less used but has been advocated by a number of these galvanizers. What they do is they galvanize as a smooth surface and then mechanically profiling. One of the method is having a grinder with a rougher wheel and then score the surface so that there are channels on the surface to make the surface roughen. And so the both are taking the galvanized surface and roughen them and then apply the paint. And then the third comparison is the thermal spray, naturally a rough surface. And then, so these three types of sample were made into test panels, and we perform the adhesion test and then also the wetting comparison. So this is an example of this is probably this is the galvanized and mechanically roughened. This is with this roughened grinder wheel, so you can see a little bit that is that these is tracks of this grinding. So you get the that way of this is one of the method to roughen the surface. And this is a surface with this both has a steel plate, and this is steel plate with the zinc thermal spraying on it, and you can see this surface is rough and the reflection on that. And the sweep blast coating is somewhere a little lighter color than this thermal spray, and these are the initial zinc coated substrates. And then so we go through using these test panels and then perform coating on it. And these we are choosing the paints are of the ones which is already approved for the net coat. So that is those are the several. We have chosen 5 different type of the paint. It's the system. It consists of the the primer and intermediate and finish coat or the top coat. So once the panel were made, painted, then what we do is two type of testing. One is this is a painted column. This has a sort of a joint welded on it, and and then we have used this one kind of the tape adhesion test, which is one of ASTM standard score the surface and test on its adhesion with the tape. Another is have glue a knob on the on the surface and perform the so-called pull-off strength test, and we see that what strength is needed to pull them off. And now, for different paint, before we paint it, we have this roughened zinc surface, and we put drops of the freshly prepared, formulated paint, liquid paint, on the surface and measure its surface tension, and as a function of time, and that is a measure of the wetting process. So now this is the standard the pull-off strength test is basically this knob glued on the surface, and then there's a hydraulic pulling, and we measure what kind of how many pounds per square inch of that pulls off. Once it's pulled off, then we are examining which layer is being removed. If all the paint is removed, like this case, it's left. You see the bare zinc in there. That is a weak adhesion. Well, it's the strength that will show it's weak, and also we are able to tell which interlayer is the weak spot. And now in this is a good adhesion. We pull it off. It's only part of the top paint get removed, and the underlayers are all intact. And usually this has a very high pull-off strength. Okay. So another is we put the liquid droplets that's onto the surface, the roughened surface. And then this is initially when you put it on, and we take a measure the contact angle after 5 seconds when the droplets is on there. And this is liquid paint which spreads. This is liquid paint. It's difficult to spread, and we find that this eventually this all spread out. But when we capture it at a earlier time, we can have this distinction. This is a high contact angle. This is a low contact angle. Eventually, they all wet the surface. And so what our question is, could we use the contact angle to make a prediction of which paint and which surface is a good match? Okay, and intuitively, we think that's better wetting. This is not so good. And is there a quantitative correlation which we can rely on? Okay, we are running out of time. I will, well, we do tests, and let me go to, and these are the contact angle measurements equipment, and these are some of the contact angle. And we collected, well, this is hundreds of test cases. And what we have is interesting is the correlation. The pull-off strength is high when the contact angle is low, okay? And so it's not perfect correlation, but these tells you that if you already have, and this is includes all three different kind of surfaces. Okay, so irrespective to what surface you use, if you get a lower contact number, contact angle, then gives you a better strength. So and this is dependent on which kind of a paint you are using. So if you have a certain before you paint it, you can have the same kind of the contractor paint a panel along with the bridge, test there, and then not a paint. I mean make it a zinc coating. And immediately then you can have a decision. You say, what paint I'm going to use? I have a choice. And your choice would be that going to the lower contact angle. So that's, I think I should stop here. Thank you.
Okay.